In the previous part, we make an initial prediction for the values of the water level in the station or gauge height for the rest of discharges through interpolation using the two known values of the water level in the station or gauge height at the low discharge and the high discharge. Then the sum of square error or square difference and the coefficient of the determination or R squared coefficient between the actual values of the gauge height and the initial prediction for the values of the gauge height appeared, which are 6.445 and 0.9659 respectively. In this part, and to obtain a more accurate prediction for the values of the gauge height than the initial prediction for the values of the gauge height, we use the relationship between the discharge and gauge height, and this relationship is as we see here in this equation, which is Q equal CR multiplied between brackets G minus A to power beta. And this equation can be calculated as follows. The general equation for a state discharge relationship or power type curve fitting method can be expressed as Q equal CR multiplied between bracket G minus A to power beta, in which Q equals stream discharge, G equal gauge height stage, A equal a constant which represents the gauge reading corresponding to zero discharge. CR and beta are rating curve constants. The best value of CR and beta in equation 1 for a given range or of stage are obtained by the least square error method. Thus, by taking logarithm log Q equal B log multiply G minus A plus log CR, or Y equal beta X plus B, in which the depending variable Y equal log Q, independent variable X equal log G minus A, and B equal log CR for the best fit straight line of n observed of X and Y by representing X equal log G minus A on Y يساوي log Q. Beta equal and B equal as we see. Pearson product moment correlation coefficient R is equal as we see So we calculate the parameters for this equation as follows. We go to the next column and we type x, then we type y, then we type x, y, then we type x squared, then we type y squared. Then we calculate the value of x by taking the logarithm of the initial prediction for the values of the gauge height as we see. Then we calculate the value of y by taking the logarithm of the discharge values as we see. Then we calculate the values of x multiply y or xy as we see. Then we calculate the values of x squared as we see. Then we calculate the values of y squared as we see. Then we calculate the sum of these values as we see. Now we calculate the parameters for the relationship equation between the discharge and the gauge height, and as follows. So we type N beta B and CR. Then N equals the number of the observed data, which is 23. Then we calculate beta through this equation. And as we see, then we calculate the b value through this equation, and as we see, then we calculate the CR value, which is the logarithm inverse of b. Now we calculate the parameters of this equation, which is q equal CR multiply g minus a to power between brackets g minus a to power beta. So we calculate the discharge value q, by using this equation, and as we see, then the initial prediction for the values of the discharges appear. To make a comparison between the actual values of discharges and the initial prediction for the values of discharges, we go to the next column and we type error or difference. Then in the next column we type square error or square difference. Then we make the comparisons, we make the computations as we see. Then the sum of the errors or square errors between the actual values of the discharges and the initial prediction for the discharges values appears, which is 800, 1511, and this value for the sum of the square error is very high. So we make an optimization by using solver in the Excel program. And to do so, we first save the calculations in the Excel file. With the title Rating Curve Calculation Final. As we see, then we open the solver, and if the solver not exists, we go to the file, then options, then add-ins, then we choose solver, we go to the file, options, then add-ins, then we choose solver, then OK. Now we open the solver, and in it we go to the set objective, then we tick on mine or minimum error, then we go to the by changing variable cells, and in it we choose the initial prediction for the values of the gauge height except the two actual known values of the gauge height at the low discharge and high discharge, and the values adjacent to them as we see. Then in the select a solving method, we choose GRG nonlinear. Then we press on the solve. Then OK. then the square error or square difference for the discharge is reduced from 800, 1511 to 5974, and the square error or square difference for the gauge height is reduced from 6.445 to 1.46, and R squared coefficient is reduced from 0.9659 to 0.9888, as we see. And we can repeat the optimization by solver many times, as we see. By that, we have finished estimating the state discharge relationship by solver in Excel with the minimum square error or square difference for the discharge through the availability of data on the river discharge values and only two values for the rise in the water level in the metric station on the river, or gauge height on the gauge height. One of the two values is at low discharge value and other value is at high discharge value.